Hello, I'm Alexandra Call. I'm a PhD student in energy science and engineering at the University of Tennessee. Today, I will share my work utilizing satellite data, critical infrastructure data, and machine learning to understand power outage vulnerability. Do you want to live in an area vulnerable to power outages? Of course not, because when we lose power, we lose the ability to safely store food, store medicine, and utilize life support equipment. This can lead to loss of life and loss of economies. However, most of us don't know if we live in an area more or less vulnerable to power outages. This is because there is a lack of publicly available power outage data. This creates barriers to disaster preparedness and outage response. The long-term outages experienced in Houston during Winter Storm Uri are a prime example of this. Wouldn't it have been nice if we could assign each neighborhood, shown to the right, an outage probability score to understand which communities are the most vulnerable and which areas first responders should go to first? Well, that's what I'm working on, to better understand spatial power outage vulnerability to reduce loss of life and loss of property during future disasters. We start by utilizing nighttime light satellite data, which gives us a broad idea of which areas emit more or less light than others. I collect images prior to my storm and get an average idea of typically which areas emit more or less light. This allows me to create a pre-storm image. I then gather an image during the storm. This is my storm image, and I calculate the change in pixels between the two images. Pixels with a decreased value I identify as outages. I reduce those outages down to the census tract level, and I identify census tracts where 70% or more of the population are under an outage. Outage census tracts are shown below in gray. I'm able to take these detailed locations of where outages are and input them into my machine learning model. However, it's also important to account for external factors, such as critical infrastructure. Proximity, density, and quality of critical infrastructure can play a major role in outage vulnerability. I take into account proximity to hospitals, schools, electricity generation infrastructure, transmission line density, transportation infrastructure, and tree coverage. I input this critical infrastructure data into the machine learning model as well. This will help understand which variables play the greatest role in outage vulnerability. We are able to successfully predict outage vulnerability at the census tract level. Each census tract below is assigned an outage vulnerability score on a scale of 0 to 1, 1 being the most vulnerable. Most vulnerable areas are highlighted in black and least vulnerable areas are highlighted in white. We're also able to understand which variables contribute the most to vulnerability. We found that distribution line density, tree coverage, and proximity to local law enforcement stations played the greatest role in outage vulnerability. This information is extremely important because 1, we've developed a novel methodology for taking broad nighttime lights outages and reducing them down to a very fine, usable scale. Knowing where these outages are at a detailed scale allows us to better identify vulnerable infrastructure and vulnerable people. This will better inform outage preparedness and disaster response decisions. Thank you for your time, and I welcome questions.